Hey guys, welcome back to another Mualpha Data Math Tutoring to Go IM1 video. Today we're going to be continuing our series of types of transformations, but today we're going to be focusing on reflections. Okay, so before we get into some more specific examples, we're just going to do a brief overview. When we're talking about reflections, what we mean is that we're starting with a specific shape and then we're reflecting it over either a line or a point. So when you're looking at a shape, each point on the shape has a coordinate, which typically we would write as x, y. Now, if we're reflecting a shape over the x-axis, for example, that will change what our coordinates look like. So we can write that by saying x negative y. And that's because when we reflect it over the x-axis, our x coordinate is going to remain the same, but since it's on the opposite side of the x-axis, our y coordinate is now going to be negative. And let's look at how that would be impacted differently if we were to reflect it over the y-axis. So once again, we'd start with the values, the coordinate x, y. But then when we reflect it over the y-axis, it's going to look a little bit different. So the y value is going to stay the same, but our x value is going to become negative because now it's on the opposite side of the y-axis as it was before. Now, when we're reflecting something about the origin, we are essentially rotating it a full 180 degrees, and we are changing the coordinates of both its x and y components. So instead of just changing x or y, we'd go from the coordinate xy to the coordinate negative x, negative y, which would look something like this. Now, let's get into some examples where we can apply this in different situations. Okay, so for our first example, we're going to start with something we just talked about, which is reflecting a shape over the x-axis. So before we reflect a shape and actually plot it on the graph, it's a lot easier to write down what our image points are and then what the points will be after the reflection. So that way we can easily plot it. So let's look at that. So looking at the coordinates of u, we can see that is -3, 5 in the original image. So let's write that down in our pre-image table. -3, 5. So then if we're looking at x, we can see that it's 0, 5. So we'll write that down here. And then L is -3, 1. So now in order to figure out what our image points are after the reflection, let's apply what we just talked about earlier. When we're reflecting something over the x-axis, it's going to come down this way. So if I were to reflect L, it would come to right about here. So as you can see, the x coordinates remain the same, but since it's flipping over the x-axis, the y values are going to be opposite. So it's going to be the same value, the same magnitude, but a negative number. So if writing that down here, it would look like -3, -5 for u because our x value remains constant and our y value has the opposite sign. And then for x, for our image coordinate, it would be 0, -5, and L would be -3, -1. And when we're doing our image, we use this apostrophe, which means L prime or X prime, and that just differentiates the pre-image from the image so that it's clear when we're graphing it. So now let's look at how we would graph that. Okay, so I can use this table that we created. So if I'm plotting u prime, I would go -3, -5, 2, 3, 4, 5. And that would be right about here. And then x, let me label that. So u prime. And then I can see that x is 0, -5. So I go 0, 1, 2, 3, 4, 5. And that's going to be x prime. And then L, I can see is -3, 1. So that's going to be right here. And then I can just connect those. So that's going to give me something like this. And as you can see, this shape has been reflected over the x-axis. It has the same x values, but opposite y values. So let's try a couple more examples. Okay, so for our second example, we're going to be looking at something that is not exactly like what we discussed before, but it applies the same concepts and works very similarly. So we're going to be reflecting across x equals 1. So just to visualize this, let's draw this line. So x equals 1 is going to be a vertical line, which is just going to cross the x-axis right there. Oh, that was a little crooked, but right about there. So when we're reflecting across a line, whether it's vertical or horizontal, each point on the shape is going to be the same distance from the line that it is on the other side. So let's do the same thing we did earlier where we write down our coordinates first. That might be a little bit easier to visualize. So let's write down our pre-image. So looking at G, we can see that from the origin. So although we drew this line, it's still going to be our coordinates from the origin. So that's 1, 2, 3, 1, 2, 3, 4. So coordinates are 3, 4. For L, we can see that is 1 over and then 2 up. So our x value is 1, our y value is 2. And then for Q, it is 1, 2, 3, 4 over and 1 down. So that's going to be 4, negative 1. Okay, so now looking at this, our graph, we can't apply the exact same concepts as if we were reflecting it across y-axis because it is not right at x equals 0. It is instead at x equals 1. So let's put it on our graph so that we're able to better visualize this. So we can see that G over here is 2 over from the line. So if we were to reflect it over this line, G prime would be 2 over this way. So it'd be right about here. You can write that there. G prime. Okay, so then the same would apply with L. Since L is directly on our line, it would stay exactly where it is because since it's on the line, but although it's being reflected, it would stay right where it is. And then Q is 3 away from the line on this side, so therefore it would now be 3 over on the left side when it's reflected. Okay, so we're just going to connect these lines to create a rough shape that is pretty similar. And as you can see, that's just reflected over x equals 1. So now we can write in the coordinates from earlier. So looking at that, we can see that G prime, and again, we're still counting it from the origin, not from x equals 1. So it would be negative 1, 1, 2, 3, 4. Since it's reflected over this vertical line, the y values are staying the same, similarly to how it would be when you reflect it over the y-axis. So with L, as we said earlier, it's the exact same value since it's on the line that we're reflecting over. And then Q prime is going to be down 1. So we know that, like I said earlier, that our y values stay the same. And then it's 1, 2, negative 2. It's 2 to the left of the origin. Okay, so for our final example, we're going to be doing something a little bit different than what we've been doing before, where we're going to be reflecting over a diagonal line, which is going to be y equals negative x in this case. So let's draw that line. That's going to go straight through the origin, and it's going to have a slope of negative 1. Okay, so when we are reflecting over a diagonal line like this, when we're reflecting over y equals negative x, our shape is going to be the same distance from the line, but since we're reflecting over this diagonal line, essentially our x and y values are going to swap, so our vertical and horizontal distance are going to flip. And since we're reflecting over a line with a negative slope, it's going to make both our x and our y values negative. So essentially our coordinates are going to go from being x, y, to negative y, negative x. So this is going to be one of those where it's going to be easier to write out what our pre-image and image points are before we start to draw our shape. So let's do that. Okay, so looking at D, we can say that counting from the origin, it's 1, 2, 3, 4, 5 over, and 1, 2, 3, 4 up. So our coordinates are going to be 5, 4. And then for Z, we can see that it's 1, 2, 3 over, and 3 up. So our coordinates, pretty easy, are just 3, 3. And then for M, we can see that it's 3 over and 0 up. So our coordinates are 3, 0. And for P, it's 1, 2, 3, 4 over and 1 down. So it's going to be 4, it's going to be 4, negative 1. Okay, so now applying these coordinates that we wrote down here after we justified that, after looking at the line, let's switch up our image coordinates. Okay, so for d prime, we know that it can become negative y, negative x. So that means that if our y value is 4, then our x value is going to be negative 4. And if our x value for the pre-image was 5, now our y value is going to be negative 5. So for z prime, that's going to be pretty easy since it's the same number, so it's going to be negative 3, negative 3. For m, it's going to become 0. I mean, technically negative 0, but that's not a number, so it's just 0. And then negative 3. And then p prime is going to become 1. And it's important to pay attention to this because it was initially negative 1. When we're putting that negative sign in front of it, that now cancels out and it is a positive again. So that becomes 1, negative 4. So now that we have our coordinates, we can draw that out. Okay, so we know d prime is negative 4, negative 5. So 1, 2, 3, 4 to the left, 5 down, 3, 4, 5. Okay, so it means d prime is right here. Okay, and then z prime is 1, 2, 3 to the left, 3 down. Okay, so z prime, you can label as being right there. M is 0 and then 3 down, 1, 2, 3. So m prime is right there. And then finally, p prime is 1, negative 4. So 1, 1, 2, 3, 4 down. So that means p prime is right here. So it's going to be right here. My drawing's a little bit rough, but you can see that's about the same shape, and it's now been reflected over y equals negative x. So that's how you're going to do a reflection over a diagonal line. Okay, thank you guys so much for watching, and please stay tuned for more Muaha Data Math Tutoring to Go IM1 videos, where we will be covering more videos on transformations. Please feel free to reach out to any of your Muaha Data officers if you have any questions or video requests. Thanks again!